For section 2.5, the precise definition of a limit, we have some examples over here. So this one is asking to prove that the limit of 2x plus 1 as x approaches 1 equals 3. Let epsilon be greater than 0, be arbitrary, determine delta as a function of epsilon. So this is what we're going to be doing. First, let's identify everything that is provided for us. So just this portion here is telling us a lot of things that we need to know. For instance, the function itself is 2x plus 1. A is the x value that we're approaching, so that is 1. And L, that's the limit is 3. So these are things that we need to know. And so this is how we're going to set it up. The absolute value of f of x minus the limit is less than epsilon whenever the absolute value of x minus a is less than delta and x is not equal to a. So this 0 less than means that x is not equal to a. So you can ignore that portion. So with the information that we have, basically it says the absolute value of 2x plus 1, because that's the function, minus the limit is 3, is less than epsilon whenever the absolute value of x minus 1 is less than delta. And so our goal is to find delta. Let's go back to the first inequality. We need to simplify. This is 2x minus 2 inside the absolute value less than epsilon. Now what we want to do is we want to make it look like this here. We want to make it look like this inequality. So let's factor out a 2. If I factor out a 2, I end up with x minus 1 in parentheses less than epsilon. Now, this should have been multiplied, so I can separate it. This is the absolute value of 2 times the absolute value of x minus 1 less than epsilon. But the absolute value of 2 is just a 2. And so I want to make it look like this other inequality. So I just need to divide everything by 2. And so see how the absolute value of x minus 1 is less than epsilon divided by 2. We say that delta is equals to epsilon divided by 2. The next one is very similar. So same instructions. Let's identify the things that were given. So the function itself, f of x, is 1 over 8x plus 7. Little a is negative 6, because that's the number that we're approaching. And L, that's the limit, which is 25 over 4. So these are things that we need. This is how we set it up. The absolute value of f of x minus L less than epsilon whenever the absolute value of x minus a is less than delta. Now, let's plug in everything that we know. We know that the function itself is 1 over 8x plus 7 minus the limit is 25 over 4, less than epsilon. Whenever the absolute value of x minus a is negative 6, so because it's double negative becomes plus 6, is less than delta. Now let's simplify. The 7 minus 25 over 4 is 3 over 4. That's an epsilon. Now if we, because again, the goal is to make it look like this one. So let's factor out a 1 over 8. When we do that, we get x plus 6, because, I mean, if you want to make it an 8 on the bottom, you multiply top and bottom by 2. So you factor out a 1 over 8 and you're left with a 6. Then you separate what's inside the absolute value, but the absolute value of 1 over 8 is just 1 over 8. Absolute value of x plus 6 less than epsilon. And in this case, you can divide both sides by 1 over 8 or multiply everything by the reciprocal of 1 over 8, which is 8. So the absolute value of x plus 6 is less than 8 times epsilon. So in this case, we say that delta equals A times epsilon. Find the largest value of delta that works for epsilon equals to 0.01 for the limit of negative 5x plus 5 as x approaches 3 equals negative 10. Things that we know is f of x equals negative 5x plus 5, little a is 3, and L is negative 10. So again, the absolute value of f of x minus L is less than epsilon whenever the absolute value of x minus a is less than delta. Things that we know, the function itself is negative 5x plus 5. L is negative 10, so double negative makes it a plus 10, is less than, and now we have a value for epsilon, which is 0.01, whenever the absolute value of x minus 3 is less than delta. Simplify inside the absolute value, we get negative 5x plus 15 is less than 0.01. Again, we want to make it look like this here, so let's factor out a negative 5. We get x minus 3 less than 0.01. Separate the absolute value. The absolute value of negative 5 is just a 5, and so we divide both sides by 5. And in this case, let's see, we get the absolute value of x minus 3. So in this case, we have 0.01 divided by 5, which is 0.002. 0.002, and so delta is equal to 0.002.